Okay, good morning, class. What I want you to do is turn to problem 19 here. And it says, in problem 19, it says, use the binomial theorem to find a polynomial expansion for the function. And I'm going to go ahead and abbreviate this problem by saying, by changing it, just to shorten it. And so instead of finding the whole expansion, we'll say find, so I'm changing the problem to make it shorter essentially. Find the fourth term. In expansion. Okay, so would you have an idea of how to go about this? Justin shakes his head no. Do you have an idea to go about this? Any idea? Anybody have an idea on how to go about this? No? Okay. Well, I know I'm going to have this thing right here. I'm going to have some combination of this. My first term is going to be something like this times, I'm going to have this 2x to the power of 7. And then I'm going to have this negative 1 to the power of 0. And this will equal 0. And I'm going to have this coefficient here first, which is 1. Because the first one is always going to be 1. Right? And then we're going to have plus, our second term is going to be this one right here. And we're going to have 2x to what power? To the 6th. And we're going to have negative 1 to the power of 1. And what number is going to go out here? Okay, the number is going to be 7 because the second term is always going to be the equivalent to that thing here. Now, the other ones here, so we could calculate these out and get the first and second term. We just simplify, we have them. Now for the third term, what we have is some number that we find, which is the NCR number, and we're going to have 2x to the 5th and negative 1 to the second power, and we would just find this and simplify, and we'd have our answer. And now, to find the fourth term of expansion is our next one right here, plus some number here, and it's going to be 2x to the power of 4 and negative 1 to the power of 3, and then some number that goes in here in the simplification there. And so how do we find this number that goes here? Okay, what we do is we do an NCR, and what numbers do we use?
7.
We use 7, choose what? It'll be 3 because we always use this one right here, whatever the y is. So we go to 7, choose 3 in our calculator, and we get, so 7, and I go here to math, and go over here to problem, and then NCR, we put in 3, and then press enter, so we get 35. So 35 is what goes here. And now to simplify totally what this is, what we have to do, our answer is going to be negative 1 to the third power. And what's negative 1 to the third power?
3i.
What's negative 1 times negative 1 times negative 1?
Negative 1.
That'll be negative 1. So what we're going to have is we're going to have negative 1, which comes from here, times 35, times 2 to the fourth power, and we're going to have x to the fourth power, and once we simplify everything, that's going to be our answer. So what's negative 1 times 35? That's negative 35, and what's 2 to the fourth power? 16. So it's going to be negative 1 times, it's going to be negative 1 times 35 times 16, and what is that?
Negative 560.
Negative 560. So our answer to this question, the fourth term expansion, is going to be -560 x to the fourth power, and that will be our answer, the way I changed it. So we didn't have to expand everything out, did we? And the reason I bring this up is because on your final, you're going to have a couple problems that are going to be like this specific about it. And when we do the review for the test, we'll have a chance to go into this and more. But I wanted to, after yesterday, get you at least exposed to this today. Does this halfway make sense to you? Okay, and then we'll have some more review on this, right? So you'll be okay. And so I think you guys are pretty good with this. So with this, we're going to go in to start talking about series today. Actually, sequence. I get series and sequence mixed up. What is a sequence? What's an example of a sequence?
1, 2, 3, 4, 5, 6.
Okay, simple counting numbers sequentially, right? 1, 2, 3, 4, 5, 6. Excellent. What would be another example of a mathematical? And by the way, that is a mathematical sequence. Okay, that's a good example of a sequence. Thank you. What's another example of a sequence? Somebody think of another one besides 1, 2, 3, 4, 5, 6.
4, 8, 6, 12.
Okay, 4, 8, right? So like kind of a skip counting thing. So that is another sequence. What's another sequence that you have? 10, 20, 30, 40. Okay, let me give you, and all the ones that you mentioned so far are what we call arithmetic sequences. And arithmetic means that they are found by adding or subtracting the same number every time.
1, 3, 5, 7, 11.
Yeah, 1, 3, 5, 7, 11. Okay, that's another sequence, and that's another example of an arithmetic sequence.
No, it's,
Okay, this is 1, 3, 5, 7. Go ahead.
1, 2, 3, 5.
Okay, 1, 2, 3, 5. That is a sequence. That's not an arithmetic sequence you're bringing up now. Okay. Here, I'll give you another example of arithmetic sequence. What about 1, -2, -5, -8, -11, -14, -17? Can you see that's an arithmetic sequence?
No.
It is, because what you're doing is you're adding -3 every time. So as long as you go up or down by the same amount, that's called an arithmetic sequence. Now I'm going to tell you about another type of sequence. And so that's one of the main ones. There's another one that's called I'll give you an example of it. 1, 2, 4, 8, 16, 32, 64, yes. So what we call this, when you multiply by the same thing to get from one to the next, that's called a geometric sequence. And so that's what we're working with. And I will show you on your ACP formula chart, there's our ACP formula chart, right? So this is your chart that has these formulas on here that we're going to use. I'll show you what they are. It comes up. Have it all set up already. Okay, there's coming up finally. Okay, problem is I got a big old calculus file on there that is about 1100 pages. Okay, so here we are, sequences and series. And so you see where it says arithmetic series, sequence, and geometric sequence. You see those? These are formulas to use to determine terms. And by the way, I said arithmetic. What does that word look like here? What is that word? Read that word for me. Arithmetic, yes. But what it is, when I said it, I said arithmetic. Here's the distinction. Arithmetic is a noun, but arithmetic is a adjective. And so the pronunciation depends on what use you have for the word. And some people just say arithmetic for either one. And it's really a fine distinct point, and I promise I'm not going to test you on that, but just realize that when you hear that, that's a difference. Okay, and so we're going to be using these formulas, and we've already, in this class, whether you know it or not, we've used this binomial theorem here today, in the last couple days. We used this one specifically yesterday, and now we're getting into these formulas up here. And so eventually, and does this look hard or intimidating or anything like that? Well, the formulas are really quite easy to use, and you even have a calculator key for this particular summation thing that we're going to use. So the thing is going to be made a lot easier than it first appears to be, which I hope will be to your liking. Okay, let's go to these exercises here. So this is a quick review, and so it's going to be really fast. We go over these things. So first of all, we substitute in for A and D and N into this thing right here. And so if we plug in, so if we have A equals 3, so we have 3 plus N equals 5 minus 1 plus our times D, and D is equal to 4. And for that, we're going to get what? 3 plus, what is this going to be?
40 minus 4 is 16.
4 times 4. So I'm going to get, does that look like that's
7 times 4 is...
No, it would be 16 plus 3 is 5.
19, okay?
Yeah.
Okay, now what it is, I think somebody said 7 times 4. What it is you got to look at order of operations on these things. Now, one thing you have that's really to your advantage, like in exercise 1 and 2, is you have a calculator, and you can store these things to your calculator and type in. Did you know that? So let me show you this. So 3 storage A, 4 storage D, 5 storage N. So I'm going to put 3 storage alpha A, right? And then what's the next one? 4 storage N? Or what is the next one?
D is 4.
D is 4, so I'm going to put 4 storage D. And then what is N going to be?
5.
So 5 storage N. And so to do that, you get this. And now you can just type in the problem, like you could do it for number 2, for instance, and get, so for number 2, we can just type this in, N over 2 times 2A, and just type this in. Can you do that? Yeah, you can. So we're going to get N over 2, which is 5 over 2 times, so I'll just put that in my calculator right now. So alpha, I'm going to put N over 2. So N, whoops, I don't know what happened there. Alpha, and I'm going to put N, that's alpha N
Should be 0.4.
over 2. You got that already?
Well, it should be.
N over 2, and that's going to be times
2A.
2A plus N minus 1D. 2A times N minus 1 times D, and there it is. Is that everything there?
Yeah.
So we enter, and so we get that.
Why
Okay.
did you put the 3 to A? A equals 3.
Let me show you why.
No, how did you get it?
Oh, let me show you how to do it again. Okay. What I did is I put, let me get out of here, 3 storage, then I pressed alpha A
Okay.
and enter. So it can just help you with that. So that's just sort of a calculator technique. Did you know, who knew how to do that before today? Nicole did. That's okay. So it's something that could help you.
Alpha what?
Yeah, it's,
You press alpha math, which gives you A. But you got to put the number first. Number, storage.
He did the plus. You didn't get the plus on the two. It's supposed to be 55.
Oh, is it? Where's the plus go here?
It's two way plus and one.
Oh, so plus goes here?
Yes.
Okay, let me see if I can go back and see if I can
Push
recreate
the up
here.
arrow. Push the up arrow.
There we go.
Oh, okay.
So now, so you say a plus sign goes right here? Okay, I'm going to press second, insert. I'm going to put a plus sign right here. There we go, that's it, right? Yeah, okay, thanks for correcting that. But that's another example. Since I made a mistake, you can press second, enter, and get back to correct prior work too. So, all right, thanks for pointing that out. That's good. So I hope you learned something about the calculator. Not much else today, right? So anyway, that's exercise 1 and 2. And now we have exercise 3 and 4. We have the same thing. Now I do want to say one thing, the vocabulary. In the language of sequence, D is called the common difference. That's in the language of sequence. And it applies to arithmetic sequences. And here you have D times certain thing. That's called a common difference. So you're going to run into that letter D here in the next few days. And this one here, 3 and 4, similar type of problem, except you have an R, and R is what is called a common ratio. So we're going to run into that starting today. So now we can work this problem out. We have A, and A is equal to 5 times R, and R is equal to 4 times to the power of n minus 1, so that's going to be the power of 3 minus 1. And then, so if we work this out, we get 5 times 4 to the power of 2. What does this thing here remind you of that we covered a little while ago? Who said exponents? Yeah, so yeah, this is like an exponential function, right? This is your initial value, this is your base, and your exponent. So geometric relations really correlate quite well with exponential functions. So what you have is you have 5 times 16, and that's going to be, is it 80?
Yep.
That's going to be 80, okay? So we're going to be doing things like that. Okay? And next, similar type of thing here. What'd you get for 4?
105.
105? And this happens to be what, when we do series in 9.5, we'll be doing formulas, this type of looking formula here. But we have A, which is 5, times 1 minus, and R is 4 to the power of 3 over 1 minus 4. So what we have here is we have 5, and 4 to the third power is 64, and 1 minus that is negative 63, and then 1 minus 4 is negative 3, and you work that all out, you should get, you'll get 5 times 11, which equals 55, okay? And for all these things here that I'm actually doing out by hand, you can do these in your calculator, right? You won't need to do this out to figure all this out like that. Okay, next. The next set here, okay, in exercise 5 through 10, find A sub 10. Well, what you do is you substitute in 10 for K So a sub 10, which I've replaced k, and we call this sub 10, as in subscript, is equal to 10 over 10 plus 1, so we get 10 over 11. All right? And then the rest of them are just very similar to that. You should be able to do those others quickly, right? And then, so you'll do that, and I'll get you a next thing to work on. That's just a quick review. We did it very quickly. That's the idea of it. I'm going to hand you another exercise set that we'll also go over very quickly. And if you don't get all these done, I'm cool with that today. You see what I'm saying? So now we have exercises 1 through 10, and we'll go over some of these. What I did last night in previewing for today is I watched these videos that I did years ago on these, and found out, well, we're not going to do all these. Anyway, on this set here, I want to do, let me see. Yeah, 1 and 2. Yeah, we'll just do 1 and 2 in this one right here, this first set. So anyway, first 6 terms and 100th term. So for this one here, first one, u sub 1 is going to be 1 plus 1 over 1, which equals to 2 over 1, or 2.
Mr. D, can we do number 9 on the other paper?
No, I don't want to do that right now. But we got to be moving ahead on this, that's all. But I could maybe talk to, if there's time, I might do that. But I don't want you to worry about that. So, yeah. So u sub 2, what you do in the place of n, in this case, is you put in 2 plus 1 over 2, which is going to be 3 over 2. And then u sub 3 is going to be equal to 3 plus 1 over 3, which is going to be equal to 4 over 3. And you see the pattern here? Then u sub 4, it's like to the denominator you add 1, and to the numerator you add 1. So this one here, u sub 4 is going to be 5 over 4. Do you see that? And then u sub 5 is going to be 6 over 5. U sub 6 is going to be what?
7 over 4.
7 over 6. Because 1 plus n over n. And then it says find the 100th term. For the 100th term, u sub 100 is going to be equal to 101 divided by 100. And so that's going to be problem 1 worked out. So what I want you to do is work out problem 2 similarly. In fact, I could call on somebody. Let me do that for number 2. Now work that out quickly and I'll call on somebody for number 2. Let's see what else we have here. Yeah, don't worry about 3 and 4. Yeah, we're just gonna do 5 and 6 too. On this one, okay. So in this exercise set here, we'll probably do 1 and 2 and 5 and 6, and that's it. Go ahead. Okay, let's see, get some help on this one here. Okay, here we go. Yeah, this, Becky, you're the one, you're the chosen one on this one here. Okay, you got number 2.
You had to 180. But because I was like, I was going to try that one before for some reason.
So you did 100?
Yes.
Okay, let's do that one at least. V sub 100 is,
It is 2 over 51.
so 4 over
100 plus 2.
102 equals 2/51.
Yes.
Yeah.
Okay, good. And then the other one, this one here is going to be, V sub 1 is going to be 4/3, right?
And then 1,
V sub 2 is going to be,
1,
yeah, 4 over 4, so it simplifies to 1. V sub 3 is 4/5. V sub 4 is
2/3,
2/3. V sub 5 is
4/7,
4/7. And V sub 6
1/2.
is 1/2, okay? So we have this pattern here. Was that you, Chloe, came up with that? Good job. I'll give you guys some credit here. Good work. Okay, what I want you to do is we're gonna go right now to 5 and 6. Okay. All right, 5 and 6. Okay, so here we are at 5, and basically what we have is this is what's called a recursively defined sequence. And basically what it is, you're given a starting number, and then you are using that start to work back to get all the terms worked out. Now it says find the first 4 terms. Well, a sub 1 is going to be our first term, and we're already given that as 8. So that's the first term of this recursively designed sequence. And now how do you find a sub 2? Well, what this is, it tells you what you need to do to get from one term to the next. So to get up to a sub n, which is 1 greater than a sub n minus 1, we have to subtract 4. So in this case, d, our common difference, is equal to -4. And so what we have to do to get from this term to the next, what do we have to do?
multiply by -4.
Right, we have to subtract 4. So 8 minus 4 is 4. And so that's going to be our second term. And our third term is going to be 0. And our fourth term is going to be -4. And now it says find the 8th term. Well, we could continue in that pattern, right? But what I want to do is, well, I'll just do that quickly. A sub 5 is equal to, what is it, -8. A sub 6 is equal to -12. A sub 7 is equal to -16. And finally, a sub 8 is equal to -20. And so this will be this will be our 8th term, and these will be our 1st through 4th terms right here. So those will be our answers, but there's a formula for that, and I'll show this to you in your ACP formula chart. It is right here. You see this nth term of an arithmetic sequence? A sub n equals a sub 1 plus n minus 1 times d. So that's the formula, and I will show it to you where I'll show you the application of that formula here. What you have is a sub n equals a sub 1 plus common difference times n minus 1. And so in this case what we have is a sub 8 is equal to a sub 1, and we're already given that as 8, plus our common difference, which is negative 4, and n minus 1, well, that's going to be 8 minus 1. And so what this is this gives you negative 4 times 7, so it's going to be 8 minus 28, which is negative 20. And where this becomes helpful for you is when you have real large numbers, right, that you can just use that formula to get to a term in an arithmetic sequence. Does that make sense? Okay. What I want to do is I want you to go do number 6, which is a similar type of a problem. And in this case, you go from one term to the next by adding 10. So I want you to work that one out, and I'll choose somebody again for number 6. How's that? Let's see if we have. Actually, we're going to do 7 and 8 as well. Yeah, we're going to do 7 and 8 on this thing as well, too.
Can a common difference be a fraction?
A common difference can be a fraction, okay, if it's the same one every time. Yeah, it can be. Now, that's a very good question, but in discrete mathematics, while the common difference or common ratio can be a fraction, your numbers here, like it's going to be u sub 1, there's not going to be a u sub 1.5. So these are all discrete things. But yes, the ratios and the differences can be fractions. Okay, let's go to our chooser for this one. This one's going to be, it's like Karina. All right, Karina, you got this one? Still working on it? Okay. Skip that one. That's not as convergence or divergence. We might skip that. 11 through 20. Okay. All right. Do you have this one here, Karina? number 6, what do you do to get from one term to the next? Add 10. So what is u sub 2 going to be? 7. And u sub 3? 17. U sub 4? 27. And then u sub 8? Thank you, Karina. Yeah, 67. And according to the formula, you can have, it'll be a sub n is equal to a sub 1 plus d times n minus 1. And so we can just use our formula, right? So a sub 8 is equal to negative 3 plus d, and d is going to be 10 times n minus 1. Well, that's going to be 7. Negative 3 plus 70 is going to be 67. Okay? That's it. Is that what you got, Karina? Okay, good. Thank you. And what I want to do is look at 7 and 8. In fact, we just may finish with 7 and 8 today on this. Okay, 7 and 8, what we have is, instead of having an arithmetic sequence, this is a geometric sequence. And so b sub 1 is equal to 2. And then what we do to get from b sub 1 to b sub 2, or b sub k to b sub k minus 1, is we multiply by 3. So what is 2 times 3? 6. And what's going to be b sub 3? 18. And what's going to be b sub 4? 54. And then b sub 8 is going to be, what did you say? I think it is 4,374. But I'm going to check with the formula, because there's a formula, and that's for a geometric sequence, and it's found right, oh, I got the wrong thing here. It's found right here. It's this thing right here. A sub n equals a sub 1 times r to the power of n minus 1. So a sub n equals a sub 1 times r to the power of n minus 1. So a sub 8 is going to be equal to a sub 1, which is 2, times r, and r is 3 to the power of n minus 1, and that's going to be 8 minus 1, or 7. So we get 2 times 3 to the power of 7. So 2 times 3 to the power of 7, we get exactly what Elizabeth said. Okay? So this is going to be our correct answer. Now what I want you to do is go ahead and do number 8, and we're going to finish with number 8 today. And for number 8, I want you to, I'll choose somebody in just a couple minutes, and that'll be it for today. How's that? It's going to be a little bit of a weird one.
Do you want these ones too?
What's that?
Do you want these?
Yeah, I'm sure. Get it. Yeah, have to make sure your name's on those. Just get them off your hands, and I'll
What
pick
about
them.
9.2?
Yeah.
So
So anyway, let's go ahead and finish this one up here. Just have a couple minutes of class left. So Robert, you're the man of the hour on this one. All right, so Robert, what'd you get for this? V sub 3 is equal to?
Yeah, I'm doing that one. I don't know, I haven't done it yet.
You just multiply everything by -2.
Yeah, I'll just, okay, multiply by
-2.
-2, so we get 3. And multiply by -2 again,
-6.
we get -6. And then V sub 8 is going to be equal to
-96.
-96. And we can find that by A sub 8 is equal to 0.75 times -2 to the power of n minus 1 or 7. So 0.75 times -2 to the power of 7. So we get -96, right? Which is the answer you gave me. Okay, so just have your names in your paper, and we'll just turn those in, and we'll just leave it at that today. I know you guys, we went through some stuff fast. You guys worked hard, I thought. And I will get these, yeah. Get these out. Let me go ahead and do this while I thought I'll do this. We'll keep the class late. Robert's suggestions.